So moving on. Okay, so I started at McMaster in 2015, so that was a while back. And I did a 16-month internship at Arcelormittal Dofasco, which is, again, the steel company in downtown Hamilton. There's also Stelco and Union Steel that I think are also down there. And I graduated this April, earlier this year, with a BEng in Materials Engineering and Science with the co-op distinction because I did more than 12 months of co-op. I also have 2 cats. Here they are. The orange one's name is Calvin, and the black one's name is Bagheera, like the panther from the Jungle Book. So going back to my time at Mac, first year was terrible. First year for most people is terrible, but for me it was really terrible because I went from having 3 courses in high school because I was a competitive figure skater to having 6 engineering courses, which made it super difficult. So my average ended up being terrible first year, which it was like almost it was a little bit over a 4, which was terrible, but like honestly, I was super happy to go into materials because that's actually what I wanted to do anyways. So it ended up working out. Second year wasn't too much better, grades wise, because still I wasn't quite understanding how I needed to work and how I needed to study in order to get good grades. But it was a little bit better because I joined the MSc Council, so the Materials Science and Engineering Council, as one of their second year reps, and at least I got sort of involved in school, which made it a little more bearable. Third year was actually better because I actually figured out how I needed to study and got a little bit more involved in school and figured out what I needed to do and what I didn't need to do in order to succeed. And then finally, in my 4th year, I got my internship. And the good thing about my internship was when I applied, they didn't look at my average as a whole, but they looked at how my grades had improved from first year to third year. And that was actually part of why I ended up getting my job, because they saw I could grow as a person and they were like, yes, we think that she can succeed. So even if your grades aren't super great in first and second year, you can still get a killer internship. It's not even a big deal. And then in my final year, I came back after my internship, completed my 5th year with no specialization, which that just means that I didn't take any specific technical electives and didn't take only specific ones, or like the bio stream or the metal stream. I just did a whole bunch of random ones, and I'll get into that a bit later. So about my internship. So the top picture here is actually of part of Dofasco, downtown Hamilton. It ranges like, I think it's like 20 or 30 kilometers between all of the buildings. Again, there's roads in between it, but we are actually a very huge company and actually have a lot of employees there, and a lot of them are engineers. So what we do at Dofasco is we take steel, which we make from the raw materials of iron, create the steel, then cast the steel into these slabs here, which are just big pieces of metal, and then we eventually turn them into these shiny coils here, which we then sell to companies to make things like barbecues or the chassis in cars and stuff along those lines. So again, depending on what the end result is, we'll have to process the steel in a different way. So in order to get my co-op at Dofasco, it was pretty easy. I applied on Oscar Plus to all of the Dofasco jobs. I honestly probably applied to about 30 or 40 of them, along with a bunch of other jobs and stuff. Ended up getting a acceptance for a video interview and a situational multiple choice quiz, which was basically a sit down in front of a computer, talk to it like a supplementary application like you would have done for Mac or for the other universities that you would have applied to. And then the situational multiple choice quiz gave you a bunch of scenarios that you might encounter at work and then tried to understand how you would have reacted behaviorally in those situations. Finally, I got through that stage and did an in-person interview at McMaster. So co-op actually makes it, the co-op office actually makes it super easy when you apply to Oscar Plus, because most of the companies that are on Oscar Plus will actually come to Mac to do the interviews. So I didn't actually have to go downtown, which made it a lot easier, because in third year you're pretty swamped with school. So trying to get to the place of your employment while doing school is kind of an issue. So this was a super good point for me. So getting more specifically into my internship, I worked at what is called the hot mill within the steelmaking area in Dofasco, where, so if you look this way, this is the way that the steel will go. So the steel comes out of the heater furnaces here, red hot, probably about 900 degrees Celsius, and is rolled down to what we call the roughing mill, where it's squished down from a slab about a foot thick to one about 6 or 7 inches. And then that is then rolled further on to what we call the finishing mill here. And at the finishing mill, we have a 7-stand finishing mill at the hot mill, which has rolls in it, which are these things you see here, that actually progressively squish the steel into a thinner and thinner bar, which is then what we coil into the nice coils that we saw earlier. So because the hot mill is so big and there are so many things that go on, I was actually tasked to just work with the coilers, which is the part that coils the long strip of metal into this toilet paper roll type thing here. So what did I actually do on my internship? So my job description when I was there was a process reliability coordinator, but it's actually called a process engineer now. I'm actually back at Dofasco for post-grad work, and I'll probably be here for a while, hopefully. So basically your job as a process engineer is to be the problem solver within the mill. So in my case, I was the problem solver with the coiler, and I was to make sure that all of the things, like defect-wise and process-wise, functioned correctly to produce the most defect-free steel. So I was the first point of communication when things went wrong, whether it was mechanical or operational. I was the one that basically figured out who to point to in order to figure out what exactly was going wrong. So that was kind of what I did on my daily stuff, where I would look at the daily defects that we produced, figure out if it was an abnormal case or a normal, relatively spiky defect that we normally get. And if in case it was an abnormal circumstance, I would then do a deeper investigation into it, which might take between a couple of days to a couple of months, depending on how bad the root cause of that defect was. Along with all of this stuff, you can also work on improvement work and project work, but again, depending on what you can do as an intern and how confident you are in your abilities, they're going to give you different types of work. And it was just lucky that I was able to succeed with what I was doing and was able to be given improvement work and project work. So improvement work and project work, again, takes a little bit longer than your daily tasks. It'll take you a couple of days, or I had a couple projects that took me a couple of months there was one that took me about 6 months while I was there. And again, it just depends on your comfort levels about the stuff that they would give you in the end. So as I stated before, I was the coordinator between mechanicals, operations, and the process guys, just because you can see as a process engineer all of what's going on based on the signals and stuff that you look at in the background. And while I was actually on an internship, I got bored one day and started to reconfigure the way that we reported out because it was just tedious and overwhelming. So I actually reconfigured the reporting service or reporting progress for the people in my position, and we actually still use that today. So how does this relate to school? I've given you a bunch of mumbo jumbo and not told you how it's related to materials. So for those of you who are in third year or are in the material stream or going into some sort of year, this relates to a third year course called Phase Transformations 3TO4. In this class, you learn about what's called time temperature transformation diagrams, which are these diagrams here. And based on the material that you're working with, whether that be copper, aluminum, steel, so within the metallurgy sort of aspect of things, you'll look at these graphs, and each of these graphs will tell you how to heat a material and then cool it to achieve certain properties of that material. So like I said prior, in my slide with the view of the hot mill, we normally heat things up to, this is in Fahrenheit, but this is about 900 degrees Celsius, and that's where the steel is completely austenitic, which means that it can be cooled based on the time that you take to cool it and the temperature at which you cool it from to all of the different phases of steel. And depending on how you cool it will give you different properties in the end result. So this is actually what the cooling process at the hot mill looks like. We have spray banks that actually cool the material as it goes from the finishing mill to the coilers. And depending on how we cool the steel and how fast it's going and what the original temperature of it was, we can then create all of the mechanical properties of the steel, even if it's going to be processed further along downstream. So I went straight into work. Did I ever consider grad school? So grad school was always something that I thought I would like to do. This is why I ended up trying to keep my average up in the last 2 years of school, so third year and fourth year. Again, averages only matter if you're going to apply to grad schools outside of Mac. If you can have a good relationship with the profs at Mac, you don't really need to keep a high average as long as they know that you can do the work. But it was just, I would like to have kept the door open for me just in case I wanted to do something cool. But along with me not being specifically interested in any type of research outside of what I had learned, my internship actually told me and taught me that I really like to get paid and have my weekends off. So I decided that instead of going more school, I would go and work for a couple of years, and who knows, if the opportunity comes up and I really want to go and research something, I always have that door open for me later on in life. So, talking about later on in life, where do I see myself 5, 10 years from now? So, I probably still see myself working at Dofasco. The company is so big that I can actually work there for my entire life without being in the same area for more than 5 to 6 years. It also allows you to grow because there are management positions that you can work towards, and if you possess the interest to work in management, they will allow you to get there and they will put you in programs in order to let you succeed, which is nice. Um, Again, like I said earlier, I'm always available for new opportunities that come up. Like, again, maybe a cool polymer company will open up with a dream job of mine somewhere down the line. But who knows? Like, all I knew from my studies, which is where I'm bringing back all of my study work, um, in my actual educational years at Mac, I didn't specialize in my program. I took a bunch of different electives from all four streams, so that's the bio, the metallurgy, the semiconductors, and then the computing. I took a bit of courses from all of those, and by taking a variety of courses, I figured out where I didn't want to work in the future, which is why I have left open bio and polymer E, which is kind of bio-y, and the metallurgy. I really don't enjoy semiconductors or the computing stuff. So that is my understanding of what is with the stream program and materials, is that you can specialize, but it doesn't show up on your final degree. And if you don't specialize, you might not know what you like and you don't like. So that's what I did, and that's why I am. And you know what? Materials are everywhere. You can basically work from Maple Leaf Foods with all their packaging and stuff to where I am now with Dofasco to probably Tesla in the States if you wanted to. So it doesn't really matter. So we can go anywhere, which is really cool. Uh, does anybody have any questions? I'm sorry if that was really fast.